All right, now we're getting to our last problem, which is our ANOVA. So we're working with an iris data set. I want to see if species affects sepal length at a 10% significance. So we're looking at species. So let's go ahead. I'm going to pull in R. I'm going to use our setup code here. So we're working with the iris data set. So I'm going to say iris. And we can see some information here. Excellent, excellent. And probably a summary of iris would be helpful. Let's develop it. Let's do summary of iris. So we have sepal length, sepal width, species, et cetera, et cetera, et cetera. So what we're going to do, let's select from iris, and I want to select species as my variable, and I want to select sepal.length. And then I don't want any other. So I'm selecting my columns. So let's go ahead. We can now do this. We can do the summary of our data set. Looks good. It's already actually setting it up as a species, but again, let's do it systematically here. So we're going to do, I'm just going to call it little species. Actually, I'm going to call it S. And then I'm going to have rselect1, and I'm going to have that as a factor. I'm going to have SL sepal length as my .numeric. Numeric. And then everything else, I'm just going to delete. All right. I can, again, let's look at a summary of our data. Looks good. So now we're going to do our ANOVA. We still keep our data set, but now I'm going to do my ANOVA. I'm going to do my numeric, which is SL squiggly S. One-way ANOVA. So let's do here. And it is indeed statistically significant. Makes sense. Degrees of freedom. Let's see, is it a large factor or small factor? It's a very, very large factor. Let's go ahead and we can do our games howl. And we can do, again, SL and then S versus species. We can see, and actually, let's go ahead and let's plot this. So on my x-axis, I'm going to have my S, my species. My sepal length is going to be here. Let's look at a plot. So we can see here, and actually, let's if I want to maximize my sepal length, setosa versus this, is going to be versicolor is definitely, all these are statistically significant. So I want my species virginica to be in order to maximize my sepal length. Excellent. Done. Repeat now for petal length at a 1% significance. So to make my life easy, what I'm going to do, I'm just going to copy the same thing. So instead of species, but let's look at the summary. I'm going to look at petal length. Excuse me. Let me read this problem carefully. Repeat how species can affect petal length. Okay, so now instead of sepal length, petal length at a 1% significance. So I'm just going to go with the same thing here. I'm going to keep the same variables, even though it really means petal length. The ANOVA. So we can see here, definitely still statistically significant. Very, very large factor size. We can see they all look to be significant here, but let's look at the plot. Yep. So they're all statistically significant if I want to find it to be virginica, and that's it. End of the row. So that is our last exam problem. So see you on the next one. Thanks. Bye.